It is called logarithmic functions, and logarithmic function is just the inverse of an exponential function. And they start off since y equals a to the x is 1 to 1. You know what 1 to 1 means? Okay, it means that for every x there is exactly one y, and for every y there's exactly one x. So unlike a parabola is not 1 to 1 because it doesn't pass the horizontal line test. Okay, but for each x there's exactly one y, but also for each y there's exactly one x, which is not the case for a parabola, right? Because you have the same y value with the different x's. Okay, so a parabola actually doesn't have an inverse. You have to break it into two parts. Okay, but do you guys remember if you have an inverse? If you have an inverse of a function, it's a reflection over the line y equals x. Do you remember that? Okay, and so if this is the graph of y equals a to the x, this must be the graph of what? Now y equals a. How do I find the inverse of something? Well, no. What do I do with the x's and y's?
Switch.
Just switch. So this is the graph of x equals a to the y. Okay, and that is called the logarithm. So this is the logarithmic. I always forget where the i's are in logarithmic function. Okay, but you don't like to have a function in terms of x, right? You want to have it in terms of y. So really, when you're finding a logarithmic function, you're finding an exponent. Y equals log base a of x is equivalent to saying x equals a to the y. So what this says is, what exponent do I need to raise a to in order to get this x? We'll talk more about that in a minute. Okay, but this x equals a to the y is another form of the log function, which is this. Okay, and what people did using some complicated algorithm, they figured out exactly what exponent you need to raise a to in order to get x. Okay, and so basically, if this has the point on the graph 0, 1, what point would be on the graph here? 1, 0. And if this has the point 1, comma a, this would have the point what? A, comma 1, and so on. Okay? So, and this has an asymptote at y equals 0. Where does this have an asymptote? At x equals 0. So a log function is just the inverse, okay, of an exponential function. And its reflection over the x-axis, I mean the line, not the x-axis, over the line y equals x. And you can get it kind of by switching the x and the y's, but then people went and defined it as y equals log base a of x. Okay? And logarithms are really good when you're trying to express very, very large numbers, like when you're dealing with like decibels or magnitudes of earthquakes and stuff like that, because the log of something is an exponent. So if you're talking about 10 billion or something like that, you could express that as a logarithm, and it would be a lot more manageable number. And it's a good way to solve when you're solving for exponents. Okay? So, like I said, this thing down here, this is called the base. Okay? This is called exponential form. exponential form, exponential form over here, this one, and this over here is called logarithmic form. Logarithmic form. And so they'll be asking you to switch from logarithmic to exponential form and so on and so forth. Okay? Log base 10, if I have y equals log base 10 of x, okay? This is called the common log. And there's a button on your calculator that says log, okay? And log base 10 is equivalent to writing, if it's a base 10 down here, it's equivalent to just writing log without the 10 down there. So if you just write like this, it's understood that the base is 10, okay? So this says 10 to some power would give you x, okay? And we'll talk more about that in a minute. But for instance, say they ask you to, I'm going to talk about that. What's the log of 100? What's the log of 100? Why? That's right. Vegan, why?
10 squared is 100.
Right, because it says 10 to what power gives you 100. You understand that? So a lot of times you have to think of it in exponential form, but it's saying the base here is 10, so 10 to some power gives you 100. 10 to the 2 power gives you 100. Okay? And so the answer to that is 2. What is, so you don't always have things in base 10. Sometimes you have things in base 2 or 3 or base E or something like that. Your calculator can do this for you. So if you hit the log of 100 in your calculator, you will get out 2. Okay? But if you have something like this, log base 2 of 8, your calculator cannot do that in that form. Most calculators, I don't think, I think maybe the 8 and 9s can do that without using a change base formula. But what is the answer to this? 2 to what power gives you 8? 3. Right? Easy? Okay? So 2 to what? Whoops. 2 to, I tried to write without it. 2 to the 3 power equals 8. Okay? How about log base 2, so now it gets a little bit tricky, of 0.25 equals what? So if you can't do it right in your head right away, the best way, the best way to do it is to write in exponential form. So rewrite this as 2 to the y power equals did I have a 2 there?
Yeah.
Is equal to 0.25. That works. So what fraction is equal to 0.25? 1/4. So what would y have to be in order for this to be 1/4? -2. Do you see where Keegan got that from? Because 2 to the -2 power equals 1/2 squared, which is equal to 1/4. So the answer to this is -2. So that's you have to kind of think a little bit, right? Kind of tricky. Because rewrite as this, how can 2 to what power is 0.25? Now you can't always do them without a calculator, but when you take this test and when you take a quiz and on your homework, you should try doing the problems that say without using your calculator, without a calculator, because you could use guess and check 2 to some power is 0.25. But that's what. You have a question, Paul? No. Just stretching? Okay. So we talked about logarithmic form, exponential form. Graph of the log function. Let's get some graphs. What's that? I don't know what that is. Graph. I don't know what all these things that show up are. I guess that's a trash can. I've never figured, I've been using this thing for like 5 years. I still don't know what that does. Graph of Mr. Beamer probably does. Of a log function. If you have, oops, let's not do that. Let's do a good solid line. Put arrows on the end. Pink. We like pink, right? Okay, so the graph of a log function, basically, we already kind of talked informally about that. Looks kind of like that. And if this is y equals log base a of x, okay, this point here is going to be what? It will go through 1, 0. Okay? This point here will be a comma 1. This point here would be,
I think it's 1A.
no, a comma 1. A comma 1. That's 1. Yeah. Because the exponential, you could think about it in reverse. The exponential function would have the point 1 comma a, right? So that has a point y equals a. And also this point is 1 over a negative 1. So those are kind of some common points for a logarithmic. Those are kind of some common points for the basic log function. Okay? It has domain. What's a domain? Right, and what are those? Where does it start? Will it ever cross this axis? No. So the domain goes from 0, not including 0, up to infinity. The range goes from negative infinity up until infinity, okay? So that means if you try to take the log of a negative number on your calculator, what's going to happen? You can't do it. You're going to get an error, okay? Because you can't raise something to an exponent and get a negative number. That is basically, that's what that's like.
Isn't there a limit?
What?
Isn't there a limit for the range?
Nope. Goes up forever. Whoops. It goes up forever, but it goes up very slowly. Okay? So even though a logarithmic function, it goes down really fast, right? But once you get up here, as you plug in very big numbers, it keeps going up, right? But it goes up slower and slower and slower and slower. That's why it's good for expressing very large numbers, because the y values are going to be very small for very big x values, because you're talking about exponents. Yeah, but it keeps going up, but it goes up really
So does it
slow.
have an asymptote?
It has an asymptote. It has an asymptote, a vertical asymptote, at x equals 0. Okay? But it does not have a horizontal asymptote. All right. Domain, range, intercepts, y-axis, and it's increasing always. If it is a increasing, unless it's like a negative in front of the log, then it would be going kind of downhill like that. But that would be in front of the whole thing. Okay? So then, using that, you should be able to, like, from that graph, you could sketch. So they might ask you to, let's go down, like sketch log of y equals log of x plus 2. And this just kind of, what's that going to do to your graph? Just like it does to a parabola and stuff like that. Shift it 2 to the left, okay? So this would be 2 to the left. So that thing, so instead of this being 1, 0, it would be over here at negative 1, 0. So you can kind of take those key points and you can move them over, and it would look, if I were to graph that, it would look something like going through here and kind of parallel to this, but going up that way as well. Yeah? Okay. What would log of x minus 2 do to your graph? What would that do? And this is not in parentheses, so it's like this. What's that going to do?
Shift it down.
This would move it down 2. And then you can put a number in front of it to kind of shrink it. Or a negative sign. What would a negative sign do to it? A negative sign in front, right, would flip it over the x-axis. Okay? And so on. All right? Yes? No? Maybe? We're good? Now we got to talk about natural log functions. Oh, not that much more. Ready to learn about natural logs? Natural logs. Do you want me to go back? Or you guys want to write down more stuff? You're okay? Okay. Natural log is just so ln x, phi equals ln x is the inverse of of what? Of y equals e to the x. So if I were to interchange, so if I want to write this, find the inverse of this, that would say x equals e to the y. So y equals natural log of x is equivalent to, so this not equal to, but it's equivalent to saying x, oops, I should have a y in there, not an x equals e to the y. And again, this is logarithmic form, log form, and this is exponential. And so natural log of x, y equals natural log of x, is just the same as log base e of x. Okay? So this means this, but rather than write base e there all the time, they just call it natural log. And I'm not exactly sure why they call it natural log, but I think because it occurs a lot in real life situations. I guess you can look that up and figure out why they call it natural log. Maybe it doesn't have any artificial ingredients or something like that. Anyway, you can get them at Whole Foods, natural logs. Okay. Anyway. So it's the inverse of it, so it's just natural log of x. And on your calculator, you have a button, you have a common log button, a log base 10 button, and you have a natural log button. But you don't have like a log base 2 button or a log base 3. So you only have a natural log button, and you have a log base 10 button. Find. So what if they said find natural log of e to the 5? Natural log of e to the 5. What do you think? Who thinks they know that? So, if you have this, right, think about it this way. E to what power is equal to e to the 5 power? 5, right? Think, if you see something like this, think like this. This is what I do. I say, okay, this means e to some power equals this, right? So I would rewrite it in exponential form. E to the y equals e to the 5. What's y equal to? If e to the y equals e to the 5, what's y equal to? 5, right? So this equals 5. So that brings up another important point. If you take the natural log of e to the something, it's just that something. Okay? So like natural log of e to the 27.2 is just 27.2. And so on, because the natural log undoes e because they're inverses of each other, right? And so that's another way to think about it. What would be e raised to the natural log of 3? Okay? Again, since e and natural log are inverses of each other, whatever I do to this, okay, this undoes it, right? So this is just equal to 3. Or you could rewrite this in logarithmic form, which would say natural log of e, natural log natural log e, natural log of e getting myself confused. Let's just, I'll think about that in a minute, not while I'm on video. But, so this undoes this, so this is just equal to 3. Okay? What would be the natural log of 1 over e squared? E to what power equals 1 over e squared?
-2.
-2. You guys get that? So when you're trying to do these problems, think about it in exponential form. So e to what power gives you this? So e to what power gives you this? E to the -2 power gives you this, right? Because that's the way it works. Is that it? E y equals, okay. What if I wanted natural log of 1.56? Are you doing that on your phone, Jess? Oh, you don't have that app? So all you have to do is take your calculator, okay, and plug it in, right? Yeah. So natural log. So let me just show you something kind of cool. So if I wanted to do natural log of 1.56, that's saying e to what power equals 1.56. Well, you don't want to use guess and check. You want to use this key right there, natural log of 1.56. And it says that's equal to 0.44685, whatever it is, okay? Watch. Second e raised to the answer is equal to, what do you think? 1.56, see? So what I just did is I took the natural log of 1.56, which is an exponent. E to that exponent gives you that number, 1.56. Because
Or could you just have done e to 1.56 equals 0.446?
Because your calculator, because e to the 1.56? Because that's not what it's not e to the 1.56, it's e to some power equals 1.56. I don't know what that power is. That's why I have to do the natural log. Fine. Okay? So again, with natural log of x, if I were to graph it, hey, you could even graph y equals natural log of x. Y equals ln x. It looks like this. Okay? That's, you probably want to stretch out the window, but it looks very much like the common log function. And so it looks like very much like this, and it y equals ln x, which just like the regular log, it also goes through 1, 0. It goes through what point? E1. Okay? Goes through the point E1. It also goes through the points 1 over E, -1. And it also has an asymptote as the x-axis, and it is also increasing. Stuff like that. Okay. Questions about that? Vertical asymptote. And then they'll give you problems like this. What's the domain? What's the domain of natural log of x plus 3? Right. So with this, you know you can't take a natural log of a negative number. It's got to be greater than 0, not greater than or equal to 0. So what you do is you just set x plus 3 has got to be, whoops, x plus caret. X plus 3 has got to be greater than 0. Therefore, x has got to be greater than -3. Right? That would be the domain of that function. What do you think, just kind of, without using your calculator, what do you think natural log of the absolute value of x would look like?
Both ways.
Very good. Okay, how did you figure that out, Stephanie?
I just know.
She just knows. She's exactly right. It would look like this on that side and that on that side. Because, think about it, right? Plug in positive values, I'm just going to get y equals natural log of x. But if I plug in negative values, I'm going to get out the same y values, right? So it's just going to give you that going that direction. Okay? What if I did this? X minus 3. What would that do to it? Just shifted 3 units to the right. So the asymptote would change to over here to 3, so it looked like something like that. Right? Okay. Anyway. What other types of oh, I have to erase. Hey! I erased too much. All right, so y equals natural log of x. What's next? Oh, and then I have, oh, right in, I have to think a minute. Hold on. How long have I been talking? 28. Sometimes you'll see, like real life problems that use logarithms. You don't have to write this down, but it's just kind of because it's too many words and stuff. But the model T equals, not the model T, they're not talking about the Ford or anything like that. Whoa, where'd that go? Where'd that go? Here? There. But if I try to write, oh, now can I write on there? There. I can write on there. Model T, this model approximates the length of a home mortgage of $150,000 at 8% in terms of the monthly payment. How'd they figure that out? I'm not exactly sure. In the model, T is the length of the mortgage in years and X is the approximate payment in dollars. You guys don't have to worry about this, but your parents do. Okay? Find the length of the above home mortgage if the monthly payment is $1,300, and find the total interest charge over the life of the loan. So basically, if you take that $150,000 loan, like any of your parents work for like a mortgage company or something like this, they probably have mortgage calculators. Or if you take out a home loan, or if you take out a car loan, Bridget. Okay, so approximate. So this is for $150,000 mortgage at 8%. So all you do is you plug in 1,300 in, okay, and you plug in 1,300 in there, okay? And then you just plug and chug. So you get 1,300 over 300, right? So you get T equals 12 point, and we'll do more applications where you have to not just plug and chug, where you have to do some manipulation, but not yet, okay? So that's equal to 1,300 over 300, right? 1,300 over 300. And if you do that, you get that this is about 18.4 years. So that's how long it would take you to pay off a loan, because your interest each time, even though you're paying off a loan, like at the beginning of the loan, you're paying mostly interest. You know that? Like if you take out a car loan or something like that, it doesn't go down very fast when you make payments. Hey, I made all these payments, and that's why they give people a 30-year loan, because like I paid on my mortgage for like 10 years, and the loan only went down by like $10,000 or something, but that's because you're paying all the interest off, because you're paying interest on that big loan amount at the beginning. But then as the loan goes down, then you start paying off more of the principal and stuff. So it says, find the length of the above home mortgage if the monthly payment is $1,300. We did this. And then find the total interest charged over the life of the loan. So what you'd have to do that, it's 18.4 years. How many months in a year? 12 for 12 months, and each month you're paying $1,300. And probably if your parents own a home around here, they're probably paying even more, unless they're rich and they just pay it off in cash, you know. But not me, you know. I'll be paying, my kids are going to be paying for my mortgage. Anyway, so if you do that all out, you get that this is $287,000.40. And you took out a loan, and your original loan amount was $150,000. How much have I paid in interest? $137,000.40. So, like I looked at my home loan, it's kind of scary when you sign these documents, but most people take out a 30-year loan. Like I'm going to be paying like $250,000 in interest for the life of my loan. You know, you get to deduct that too. Okay, so that's almost it. The very last problem, going from exponential to logarithmic form. Just one more that I saw that might be a good one to look at. Write in natural log form, logarithmic form. Okay, if you had something like this. E equals 1.3956. Could you do that, Bridget?
Yeah.
How?
Can you just,
How could I rewrite this?
can you put that up to the third power?
Yes, you could. E to the 1/3 power equals 1.3956. So I want to write this as y equals, I want to write this as natural log form, right? So natural log of something. So what goes where? Something goes here and something goes here. E to the what power equals what?
1.39.
Yeah, right. So this would look like, if it helps you think about this, 1.3956 equals 1/3. So there's no real, you don't have to write the E there, but that helps me think about it. Okay? So I would first rewrite this as 1/3, and then say E to this power equals this, logarithmic, right? And so I just rewrote it and I got it. Okay. You can, now the homework's pretty long. Don't yell at me. You want to see it? No? It's, but you can get a start. And then, like I said, in about 20 minutes or so, I'll teach you the change of base formula on that, which you might already know, but it's pretty quick. So let me just go to that. Where is it? Don't look at my subplans. Index. Oh, it's easier to see this time because it's blue. You see that? Can you see that? You can see it. There you go. Oh, I'm still recording. And that's your homework. Okay. Bye.